class. How are my honors kids doing? I am making a video right now for lesson 16.1 in our congruent triangles unit. So we'll have two, of course, part 1 and part 2. And 16.1 deals specifically with angles in a triangle, which are very important to congruent triangles. So with angles in a triangle, all right, triangle angle sum theorem is number 1. And we're going to do two theorems here dealing with angles. First one is triangle angle sum theorem. Second one is exterior angle theorem. So we already know that the angles in the triangle sum to 180. We've already talked to you about that. And so we already know that. If we take the measure of angle 1 plus the measure of angle B plus the measure of angle C, I meant the measure of angle A plus the measure of angle B plus the measure of angle C, then we're always going to get 180 degrees. And it doesn't matter how big or how small the triangle is. We just know that it's always going to be 180 degrees. And I think that I've shown you this before. I'm just going to do a little triangle here. And I'm going to show you what this means. If I have angle 1 here, all right, and then I have angle 2 here, and I have the third angle here, and let's say that I cut this up into my triangle, angle 1, angle 2, and angle 3, and I just made myself marks so that I cut it up appropriately and I don't have to think too much, which is good. It's my 5th video, or 8th video actually today. If I line up my angles 1, 2, and 3, that were in the triangle before I cut it up, then you're going to notice that I have indeed a straight line. All right, so just a straight line there. That means that all 3 of those angles have to add to 180 degrees. And I might have shown you that before, but there it is a little bit as a reminder maybe. So 180 degrees. So we can have problems that will help us to find angles of a triangle just using the triangle angle sum theorem. So we're looking for measures of angles 1, 2, and 3. All right, so if this angle is 66 and this is 84, then what we would want to do is we would want to add the 2 angles here and subtract them from 180 to get angle 1. So what I'd like to do in my calculator, just because it makes it pretty simple, I get this to show 180 subtract the sum of 66 plus 84. That's one long line there of numbers, and I'm taking 180 and subtracting the sum of the other 2 angles. So angle 1 must be 30 degrees. All right. Now, I only have one of the 3 angles in the second triangle here. So what I can do is I can note that these 2 angles make a linear pair. So I can find angle 3 by taking 180 and subtracting 84. And so 180 minus 84 is 96. All right, so that angle here has to be 96 degrees. So that one's 96. Then I have a second angle to use to find angle 2, right there. So again, I'm just going to, I like to arrow up here and highlight. I don't know if you can tell or not that I've highlighted that line where I figured out the angle 1, and 180 minus 96 plus 43, and I can just retype over those 2 angles. So I'm taking 180 and I'm subtracting the sum of 96 and 43, and that gives me 41. So that angle must be 41 degrees. Not too shabby. All right, example 2, find the value of x. Now, you could add all 3 of these together and make it equal to 180, or to keep our numbers down a bit, note that this angle is a 90-degree angle. If that angle is a 90-degree angle, then we have a pretty cool scenario. These 2 angles are 180 minus 90, so that's 90 degrees. So these 2 angles must sum to 90 degrees because they're in the triangle and they're the difference between this angle and 180 degrees. So we've got it. We can just set their sum equal to 90 degrees. So 7x plus 3x is 10x, and 5 minus 5 is 0, and that's equal to 180 degrees. All right, so I added them. I mean, you can write out 7x plus 5 plus 3x minus 5 equals 90, and then add your 7 and 3x and get 10x, and then 5 minus 5 is 0. But I just like to add them together and write it down. We divide by 10, and we get x is 18. Okay, pretty simple, something we already knew. This next one is something you don't know. What I wanted to point out really quickly when you looked at this example is that these 3 angles add to 180, and these 2 angles add to 180, don't they? Right? So I have 3 angles that add to 180. I have 2 angles that add to 180. 3 that add to 180, 2 that add to 180. Now, I want you to notice something else. If I extend this leg right here, so I'm extending the leg, this becomes an outside angle. So if you have this triangle with an extended leg, you have an exterior angle. All right, exterior angle outside of this triangle. Now what happens is this angle is 96 degrees. This angle is the difference of 180 and 96 degrees, so it's 84. All right, now the 3 angles in the triangle add to 180 also. So if I take away the 96, then these 2 angles are the difference of 96 and 180. So these 2 angles plus 96 makes 180. This angle plus 96 makes 180. So this angle and these 2 angles sum have to be the same because they both are the difference of 96 and 180. And if you add these together, you have 41 plus 43, that's 84. So add these 2 interior angles, and it's going to be 84, just like this angle is 84, because a linear pair adds to 180 and 3 triangles add to 180, and they're both the difference of 180 and this angle 96. And what we have there is something called the exterior angle theorem. The exterior angle theorem says if an exterior angle is formed by extending any one side of the triangle, then that measure of angle 1 is going to be equal to the sum of the 2 non-adjacent interior angles. So the measure of angle 2 plus the measure of angle 3. It has to equal that sum. What I like to call these, and I don't know why it doesn't on these notes, but it doesn't, so I'm going to tell you, remote interior angles. I like that because remote means away from. Remote means away from. Interior means they're inside of the triangle, and angles are angles. But that makes it easier to figure out which ones we're talking about, which sum add to the exterior angle, because it's the other 2 angles in the triangle that are not attached to the exterior angle. So I can find this exterior angle, and I note it right here. This exterior angle is going to be equal to the sum of the angles that aren't the attached angle. They're the other 2 angles. It just makes it much easier for you to find which angles sum. So it's the non-attached, or the remote interior, the remote angles inside of the triangle. All right, so that's what we're going to do for the remainder of our lesson here. Let me show you just a really quick picture somewhere. If I have a triangle, if I make an exterior angle, I actually have 3 exterior angles. Because I have 3 angles, I can have 3 exterior angles. And you just extend the side, that becomes an exterior angle. And then I go around like a pinwheel. I'd have to extend that side to get that exterior angle. It's equal to the sum of these 2 angles. And then if I extend this side, this exterior angle is equal to the sum of these 2 remote interior angles that are not attached. So this angle is equal to the sum of these 2 remote interior angles. This angle is equal to the sum of these 2 remote interior angles, not the one that's attached, but the other 2. And this angle is equal to the sum of these 2 remote interior angles. And that might help you see a little bit better what we mean by an exterior angle versus the remote interior angles. All right, so example 3, find the value of x. Normally I like to ask you guys, but because it's on video, we're going to try to just do it ourselves this time. So this angle is the exterior angle. The 2 remote interior are the 2 inside of the triangle that are not attached to the exterior angle. And it is those 2 we add together and set equal to that one. So you have to be very careful with what we're doing. So 14x minus 13 is equal to 4x plus 6x is 10x, and then 13 plus 2 is 15. and we've got our little equation that we can use to find x. So this plus this equals that. If we subtract 10x from both sides, then we get 4x minus 13 is 15, and then we add 13, and we get 4x is 28, and divide by 4, and we get x is 7. All right. So just make sure you get the setup right. Have to have the right equation in order to find x correctly. All right, this next one is a little tricky. Now we have the scenario that we have to actually write up ourselves. So we have a triangle, and it's JKL. So I would write that first. Now K is 9 more than J, and L is 21 less than twice J. So find the measure of each angle. So you notice each time K is 9 more than J, L is 21 less than twice J. So both of them, both angles, K and L, are in terms of J. So we've done stuff like this before. We find that J is what both other angles are written in terms of. So we call angle J X. We call that X, right? First thing, we call it X. And then if 9 is 9 more than X, we can replace X with the measure of angle J. So 9 is 9K, angle K is 9 more than X. So this would be X plus 9. And then L is 21 less than twice J. So L is going to be twice J minus 21. That is 21 less than twice J. And we have both of those angles plus the original J angle that add to 180 degrees. So we have X plus 9 plus 2X minus 21 is equal to 180 degrees. Now again, I like to add all the X's. So 1, 2, 3, 4, we have 4X. And then add the numbers. We have 9 minus 21. So 9 minus 21 is 12, negative 12. And that's going to equal 180. Because they all are 3 angles in a triangle, so they sum to 180. So we'll add 12 to both sides. We get 4x is 192. And if we take 192 and divide 4, and divide 4 from both sides, we get 48. So x then is 48. All right. So if x is 48, that's angle J. So angle J must be 48 degrees. And then K is 48 plus 9, which is 57 degrees. And then L is, you know what, I'm just going to add them together and subtract from 180. Or you can plug 48 in for x times by 2 and minus 21. But it's just as easy to add these together. I get 105. So angle L must be 180 minus 105, which is 75 degrees. And we're done with that. All right, that concludes our first lesson. Stay tuned. Open up part 2, and we'll do the rest in a minute.